Alright guys, today we're diving into 1.3. We're going to be looking at how to solve and graph inequalities. Okay, first off, we're going to be looking at our section 1.3 notes, starting off with our topic of what the inequality symbols are. So they contain the following four symbols. Greater than is the first, less than the second, greater than or equal to, and then we've got less than or equal to. Feel free to write the titles out too if you want to. The types of dots that each inequality contains. Anytime that it's just a less than or greater than, meaning it doesn't have a line underneath of it, it's not an equal to as well, it's just going to be an open dot. Okay? If it is equal to, it's going to be a closed dot. The way I remember that is that if it's equal to, we're having to draw this extra line. Okay, we're doing a little bit more, so we're also going to shade it too. Okay, so do a little bit more. Remember that the line underneath of that greater than or less than sign goes with the closed dot. Okay, and then we have what is called interval notation. So what this is, if I'm going greater than, meaning that my arrow when I graph is going to be pointing to the right, it's going to be bigger than my number. My interval notation is obviously going to start at that number, so open parenthesis, and then whatever your number is, comma, and then that line's going to infinity. So that is what the interval notation is going to look like for greater than. Now for less than, it's similar, but my line's pointing left, right? So it's going to negative infinity. And then my right interval is just going to be whatever that number is. Greater than or equal to and less than or equal to are going to work the same way, except for my dot is closed, right? So that value is defined at our number. So the only thing that's going to change is that the side that our number's on is going to have a bracket instead of an open parenthesis. So again, just doing a little more, right? The line, the shade, the bracket, they're all going to go together. And then same thing for less than or equal to. I know I'm starting at negative infinity. That's still going to be an open parenthesis going to my number, close bracket. Okay? We'll work with these. It is kind of a memorization thing, but I'll show you when we start graphing why these make sense. So rule number one, if the variable is being eaten, then you graph to the right. Okay? If the variable is not being eaten, then you graph to the left. So let's look at some examples. So it says to graph and write. So given the following inequalities, graph them and write the interval notation. So we'll start with the first one. X is less than 2. So to put this on a graph, I'm just going to place the 2 in the middle. If I wanted to add more numbers, I could have a 1 and a 3 next to it. Is it going to be an open or a closed dot? It's going to be open, okay, because it's not less than or equal to, it's just less than. And since it's less than, it's not being eaten, so it's going to go to the left. The interval notation, so as you can see, my arrow is going to the left to infinity, so that's going to be my left value. Going to stopping at 2 on the right, and it's open circle, so it's open parenthesis. Then we have negative 1 is less than or equal to y. So pay attention to this one, even though y is on the other side. Is it being eaten or is it not being eaten? It's being eaten, right? So I could go ahead and put some more numbers on here if I want to, but I know I'm graphing it at negative 1 on a closed dot because it's greater than or equal to. And again, it's being eaten, so it's going to the right. So then whenever I write my interval notation, so starting from left to right, I'm starting at the number negative 1, and it's closed, and it's going to infinity. Okay, so when solving an inequality, just like an equation, but when you divide or multiply by a negative, you have to flip the sign. So given the following inequalities, solve, graph, and write the interval notation. So these are going to work just like an equation, okay? So first things first, I'm going to distribute out this 5. So I have 6 plus 5 times 2, which is 10, minus 5x is less than or equal to 41. Combine like terms, 6 plus 10 is 16, minus 5x is less than or equal to 41. I know I need to subtract the 16 on both sides. 41 minus 16 is going to be 25. I'm going to move over here just so I have a little bit more space. So I'm left with negative 5x is less than or equal to 25. Last step, I have to divide, right? But this is a negative number, which means I have to flip the sign. 25 divided by negative 5 is negative 5. And that's my answer. So now when I go to graph this, I'm going to erase just a little bit, just so I have a little bit of room under here. Okay. Negative 5 is going to be right here. If I put numbers around it, I could have negative 6 and negative 4 if I want to. Close dot on the negative 5, because again, it does have this line underneath of it. And then the x is being eaten, so it's going to go this way. How would I write the interval notation for that? Think about it. Hopefully you put this. Okay? Good deal. Special situations will occur if your variables cancel each other out, and you're just left with either a true statement or a false statement. Okay? A true statement is going to leave you with all real numbers, which this is the symbol for it. It's just a capital R with an extra line through it. Hopefully you've seen that before. A false statement is going to leave you with a no solution, which looks like this. Just a letter O with a line through it. So now we're going to keep on going. It wants us to keep graphing and giving the interval notation. So we will start with this one. First things first, distribute, right? That's our first step always of solving an equation. When we do that, we get 2x minus 3 is greater than 2x minus 10. Get the variables on one side. I need to subtract 2x. Ooh, when I do that, they cancel. I'm just left with negative 3 is greater than negative 10. Okay, so think about that. If I put those on a number line, how would it work? Negative 3 be on the right, the left? Let's look. Negative 10 is less than negative 3, right? So if I did a number line, I'm gonna run out of room. Okay. Is negative 3 greater than negative 10? It sure is, right? It's on the right side. It's closer to 0 than negative 10 is. So therefore it is greater than. So is this a true statement or a false statement? It is true. So it's going to be in all real numbers. How I graph in all real numbers? It's just a arrow going in both directions. It's defined for the entire length of the numbers in the universe, okay? The interval notation, we can see this line's going from negative infinity to infinity. So that's how we could write it in interval notation, okay? Next example, same thing, we're going to distribute first. And that's what we get there. Subtract variables off. End up with 6 is less than negative 28. I don't know about that. Is a negative number ever bigger than a positive number? No. So this is a no solution. We actually don't have a way to write an interval notation for a no solution, because it doesn't have a solution, and we don't have to graph it either. Compound inequalities. So let's move right along. Compound inequalities place two inequalities together by the words and or. Okay? So an and means it's an intersection. It's got to have both inequalities. It's just what they have in common, and it's that intersection. What it's going to look like is a line segment. Just going to look like this. Or like this. Okay? An or is just a union. It's going to look more like a gap. It's either going to look like this. Whoa, hold on. With the gap in between those two lines, or with the open circles like that. Okay, we're going to use these notations. The U is just that OR function. Think union, starts with a U, OR. And then that other function, the opposite of the U, the upside down U, is your AND function, or your intersection, okay? The way I like to remember these is, again, U looks like a union. This A could kind of look like an A, right? But it just doesn't have that line. And that's your AND. So think when you see that, think AND. Okay? A couple more examples here. So we'll see. We've got which type of function? An AND or an OR on example 6? It looks like an AND, okay? And how I can tell that is it doesn't have it separated, sorry. So it doesn't say OR in between. So this is totally just an AND function. So how I'm going to solve this is I'm going to break these into two different equations. So even though it's an AND, I can see that I have -6 is less than 2x minus 4, and then I also have 2x minus 4 is less than 12. Okay, so those are two different inequalities that are being combined into one. But I'm going to split them apart to solve them, just so that I can see what my answers are here. Okay, so the first one is -6 is less than 2x minus 4. The other one is 2x minus 4 is less than 12. Okay, so let's go ahead and just solve these. So the first step is to get that x by itself, so I want to add that 4 over. -6 plus 4 is -2, is less than 2x. And then I need to divide by 2. It's a +2, so I don't have to change the sign, but -2 divided by 2 is -1. So I have x is greater than -1. I can also write it just like this. Okay, so I'm going to write my answer over there. Again, because the x is being eaten, that's why I can change the order in which they're written. Okay, next one, add 4 to x is now less than 16. Divide by 2. We now have x is less than 8. Okay. So those are my two answers. I'm going to graph them, and then I'm going to write the interval notation. So if I graph them, put them on a number line. So -1 is going to be over here. We'll go up to 8, because we've got to include all those numbers. Okay. Looks like they're both going to be open circles. So the -1 is going to be an open circle, and then 8 is also going to be an open circle. Now how I do the shading on this, so how to make sure that this works. So this is an AND function, okay? So I need to make sure that this looks like a line segment. So I'm going to do my shading up above. Before I draw my arrows, I just want to shade and see what's going on. So for x is greater than -1, okay, so that was my first answer. I know that that means I'm going to shade to the right, right? Okay. For x is less than 8, I'm going to shade to the left. Well, what do these have in common? Because again, it's an AND function. If I go to the store and I tell you to get a Snickers and a Twix, you got to get both, right? If it's an AND. If I asked you for an OR, it would just be one or the other. But if it's an AND, I need where both of them are, which is just from this open circle to this open circle. So my arrow or my segment is just going to go in between those. Now I just have to write the interval notation. So open circles just mean open parentheses from -1 to 8. Cool. All right, the next one. Is it an AND or an OR? It is obviously an OR, right? It even has the word OR, which is good. That helps me. So they've already broken the problem into 2, which saves me a little bit of time. So I'll go ahead and just solve them. 4y is greater than 12, divide by 4, divide by 4, y is greater than 3. Next one, add 4, we get 3y is less than or equal to -1 plus 4, just going to be positive 3, divide by 3, again it's positive, so I don't have to change the sign, but I get y is less than or equal to 1. So now I just have to go graph those. Well, those numbers aren't too far apart, so I just need to include 3 numbers on my number line, 1, 2, 3. It's got to include each number and what's in between. What kind of circles on these? Well, on the 3, it looks like it's going to be open. On the 1, closed, right, because it's less than or equal to. Now I want to do my shading above, so the greater than 3, I know I'm going to shade to the right. Less than or equal to 1, I know I'm shading left. And it's an OR function, so I know that I want a gap in between these two things. So that's okay with me. My arrows are going to be left and right. For the interval notation on this one, again, it is a union, right? So it's that U for our interval notation. So how I'm going to write this one. So my graph reading from left to right, it starts at -infinity, then it goes to 1, and it would be a closed bracket because it ends there, right? And that's a closed circle. We've got a union with the graph starting again at 3 and going to infinity. So that is what an OR would look like. Okay, steps to solving inequalities when you have absolute value bars. So we know what absolute value bars look like. They make any number between them positive. Okay, so if I had the absolute value of a number equals 7, I could put in 7. I could put in -7 because the absolute value of -7 would be 7. So that's how absolute value bars work. So the first thing to do is just to isolate them. Make a decision if this is an AND or an OR problem. If the absolute value is greater than whatever is on the right, then it is an OR problem, greater. If it is less than, it's going to be an AND problem, less than, okay? Think about these words when you plug these in. So you're going to split into first problem. The first split is to drop the bars, keep it the same. Second split, drop the bars, flip the sign, and make the other side negative. Then you'll solve and graph it and check for extraneous solutions. Okay, not every solution is going to work. Given the following inequalities, we're going to solve, graph, and write them. Write the interval notation. So we look here, is my absolute value isolated? It is isolated, okay? So everything, there's nothing on that side with the absolute value. It's all by itself. So I'm ready to make a decision. Is this AND or OR? Is this a less than or a greater than sign? Less than. So it's going to be an AND problem. So I can now split it. I'm going to have, just dropping the bars here. So x plus 3 is less than 9. Keep it the same. And then x plus 3 is greater than, flip that sign, and then make it a -9. Time to solve. Subtract 3, x is less than 6. Subtract 3, x is greater than -12. So let's put these on a number line. I'm just going to increase by 6's, so I'm going to go -12, -6, 0, and 6. Looks like I'm going to have 2 open circles on 6 and -12. And now I want to shade. So for x is less than 6, that means I'm going to be shading this way. For x is greater than -12, I'm going to be shading this way. It's an AND problem, so I want it to look like a line segment. It wants to be what they have in common, right? So it's just going to be that. So that one works. But I still need to check for my extraneous solutions before I do my interval notation. So let's go ahead and plug in 6 and negative 12 to where we split. So 6 plus 3 is less than 9. 6 plus 3 is 6, 7, 8, 9. The absolute value of 9 is just 9. Is 9 less than 9? It's not, right? If this was an equal to, that would work, but it's not. So this one doesn't work. Okay, now let's try the negative 12. So negative 12 plus 3 is less than 9. Negative 12 plus 3 is going to be negative 9. The absolute value of negative 9 is 9. Is 9 less than 9? No, it's not. So this one doesn't work either. So even though we did all this work, we got this awesome little graph here, this is still going to be a no solution. Example 9. Is my absolute value isolated? No, it is not. Okay, we still have a negative 3 out front. So just like if I had negative 3x is less than or equal to 21, to move that negative 3 over, I would need to divide by negative 3. So I'm going to do that exact same thing. Divide by negative 3 on both sides. When I do that, these cancel and I'm left with my absolute value. When I divide by a negative though, what happens? We've got to flip that sign. Why did my pen change? There we go. 21 divided by negative 3 is negative 7. Okay, so now I'm isolated. Now I can split this into two problems. So the first one, drop the bars, keep it the same. Second one, drop the bars, flip sign, make it positive. Now I can just solve them. Add 1 on both sides. 2x is greater than or equal to negative 6 divided by 2. X is greater than or equal to negative 3. 2x is less than or equal to 8 divided by 2. X is less than or equal to 4. So I have my two answers here. I can go ahead and put them on a number line. So negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Close circle on negative 3. Close circle on positive 4. And let's do some shading and see what we find out. So if x is greater than or equal to negative 3, means we're going this way. If it is less than or equal to 4, we're going this way. This was a greater than sign, greater, which means or. So do these have anything in common? Well, since it's an or, your initial thought's probably like, no, this is a no solution. But we've still got to go and check our extraneous solutions because we could have an all real numbers on our hands. Okay, remember those two different things? They kind of look similar, but we've got to go check. So let's go do that. Let's plug in negative 3 again to our original problem. So let's do that. Again, we're plugging into that original 1 because it had that negative sign. So we've got to keep that. So let's go up here, negative 3, absolute value of 2. We're going to plug in the negative 3 first. Again, that was our first answer. Minus 1 is less than or equal to 21. Let's see if that works. So 2 times negative 3 is negative 6, minus 1 is negative 7. So the absolute value of negative 7 times 3, well, the absolute value of negative 7 is a positive 7, which is going to give me a negative 21. Is that less than or equal to 21? Yes, so that one works. Now let's try the other. Negative 3 times 4, 2 times 4 minus 1. Is that less than or equal to 21? So 2 times 4 is 8, minus 1 is 7. Negative 3 times 7 is, or the absolute value of 7, which is 7, is going to be negative 21. Is that less than or equal to 21? Yes, so this one is going to be in all real numbers. The interval notation for that is this. And to graph it, it's just a line going in both directions. Okay, so we've seen a no solution. We've seen an absolute value. Let's get into some others. Looking at this one. 2 minus 3, absolute value of x plus 9 is greater than 11. We've got to isolate that. So the first thing I'm going to do, treat it just like it were an equation, right? So move the variable, or the constant first. 11 minus 2 is 9. We still have this negative 3 out front. So we end up with x plus 9 is less than, we got to flip it because we divided by a negative 3. Now we can split to two problems. X plus 9 is less than negative 3. Again, this is a less than, right? So we need to make sure we realize that. And we've got x plus 9 is greater than negative 3, which is going to be positive 3. Again, got to change the sign on that one. Okay. Solve them, subtract 9, we get x is less than negative 12. X is greater than 12. Okay. Graph it, see what we get. I'm going to need to erase some stuff from the previous problem so I have my room back. Okay. Let's go in intervals of 12, so we can just do negative 12, 0, and 12. Open dots, right? Let's shade. So for negative 12, we know it's going to go to the left. X is being eaten from the 12, so it's going right. We knew from where we broke it down that this was a less than, and this would be an or problem if these arrows are going different ways, okay? But let's check our extraneous solutions and see what we've got. We'll go back up to the original. 2 minus 3 times negative 12 plus 9 in absolute values is greater than 11. Negative 12 plus 9 is going to be negative 3. Absolute value of that is a positive 3. 2 minus 9 is going to be negative 7. Is negative 7 greater than 11? No. Let's plug in the other number now. 2 minus 3, absolute value of positive 12 plus 9 is greater than 11. 12 plus 9 is 21. And 2 minus 3 times 21 negative 61. Is negative 61 greater than 11? No. So this is another no solution. Okay, let's do number 11. Try this one on your own. Let's get the absolute value by itself. It's still not by itself. I've got to divide by 2. Cool. Time to split. 2x plus 6 is greater than 16. 2x plus 6 is less than 16. Subtract 6. 2x is greater than 10. X is greater than 5 when we divide by that 2. Subtract 6 on this side. 2x is less than, ooh, I forgot to put a negative here. Negative 16 minus 6, which is going to be negative 22. And divide by 2. We don't have to flip the sign because that 2 is positive. We end up with negative 11. Okay, time to graph this one. So we need to go from a negative 11 to a 5. Go by intervals of 5, how about, so we don't have to graph quite as much. Open circle on 5. Open circle on negative 11, which is going to be right about here. x is greater than 5. It's less than negative 11. So I shaded that up above. Again, I can erase up here real quick, just so I have a little bit more room. Okay. This was a greater, and this looks like an OR function to me. Let's go plug both these values in and make sure they work. So when we do that, we go back up to the top. So 4 plus 2, 2 times 5 plus 6 is greater than 36, so check that one. And then same thing, 4 plus 2, 2 times negative 11 plus 6, make sure you get the absolute value of that value, is greater than 36. When you check both those in your calculator, you should get them to work out. So this one does work. My lines are going to look like this. Okay, I can erase that shading if I want to. And then my union for this one is going to be, it's going from negative infinity to negative 11, stopping there with an open circle. Union means this symbol, starting at 5 and going to infinity. That's it on that. Let me know if you have questions and check Canvas for homework.